This is Algebra 2, Lesson 110, quadratic inequalities. So what's a quadratic? Yes?
X squared plus x plus 1 equals 0.
Correct. It's a second degree equation, 4 terms, right? 4 terms, second degree equations. And typically, how many x-intercepts do we have? How many? 2. That's right. It's 2, 1, or none. But at most, we have 2. And so when we have an inequality, well, what else do you know? That the graph can either do one of 2 things. It can either open up or down. All right, so we'll just graph one up and we'll graph one down. So if I were asking whatever this function is, what happens in that function when it's greater than 2? What am I asking? What does this value represent?
A number greater than 2.
Okay, but what does f of x represent?
Y.
Your y value, right? It's your y value. So when it is greater than 2, we'll say this is 2, all right? It would include the range here and up, right? And here and up, really like here and over, right? And here and over. We're gonna keep that looking at that one. All right, so let's just say this is where x is -3 and 4. All right, so it would be values where x is less than -3 and values where x is greater than 4, right? So greater than is always going to be a disjunction when we have a quadratic. Always, always. Your greater thans are always going to be disjunctions. Got it? All right, now, what if I asked you, instead of greater than, what if I asked you less than? It's a conjunction. It's all of this range, right? I'm now thinking I'm drawing in Christmas. All right, so it's always going to be a conjunction. Your less thans are always going to be a conjunction when we have a quadratic equation, all right? This disjunctions are in lesson 110. Conjunctions, less than, greater than, disjunctions, lesson 110. Less than, conjunctions, lesson 112. So we're going to deal with greater than first, our disjunctions, all right? So always, you see, and I've told y'all this, you see greater than, you think disjunction, our values are going out, away from one another. Okay? Always, always, always think that. All right, so I'm teaching this different from your textbook. Okay? Your textbook has you do 2 trials and see which one works. I have you do a number line and you know which works. Okay? All right. So let's look at example 1. It's x plus 2 times x minus 3 greater than 0. We're always using all reals. All right. Now, let's think logically through this. in order for the product of these two terms to be greater than 0, what must be true of the individual terms?
They have to be a first degree.
Well, they're both first degree. Yes?
They have to be, it's like neither one of them can be 0. Or it would be.
Neither one can be 0, right? That is true. Neither one can be 0. What else must be true?
They both have to be.
Can't be negative.
Okay.
Wait,
Only one can't be negative.
Yeah,
Both
they either have to both be positive or both be negative.
That is correct. So you were on the right track. So either they both must be positive, because a positive times a positive is always going to give me something greater than 0, right? Or they must both be negative, because a negative times a negative gives me a value greater than 0. All right, so you draw a number line. And we look at what the zeros are. So what are the zeros for that function?
Negative 2, positive 3.
-2 and +3. You see that? All right, so -2 is lower than +3. So I look at what happens to each one of these terms in this range, in this range, and in this range. And what you're going to find is, I already know the answer because it's greater than, and it's a disjunction. So there's no way it can be this area in the middle, right? It has to be here, out, and here, out, right? But let's prove it. Okay, we're going to prove it. So we're going to choose a number less than 2. We're going to choose a number between less than -2. We're going to choose a number between -2 and 3. And we're going to choose a number greater than 3, plug it in, and see what we get, positives or negatives. Got it? All right, so what number do you want to choose less than -2? That's greater than -2. No worries. Okay.
Good job, y'all.
I know. Look, I had to do this in pre-calculus today. All right, what's between negative? Just an easy number between there.
1.
Okay, that's fine. Greater than 3. I would have picked 0, but
It's a good number.
4.
4. Okay. All right, so when I plug in -3 to this first term, do we end up with a positive or
Negative.
we end up with negative? What do we end up with here?
-6.
So a negative and a negative, that works. It makes it a positive. So it satisfies. Got it? We have to have a negative times a negative to give us something greater than 0. Got it? All right. What about 1? What happens to x plus 2? It's a
Positive.
positive. X minus 3 is a,
Negative.
that's going to give me a negative number. It's going to be less than 0. This range doesn't work. You get what I'm doing? What about 4? When I plug in 4 to the first term, we get a positive number. When I plug in 4 to the second term, we get a positive number. They can't equal the number because it's greater than. It's not also equal to. So we have an open interval. So in interval notation, this would look like -infinity up to -2, right? And it would be 3 to positive infinity. On a number line, but when you see this greater than, you're already thinking disjunction. And if you can factor it, you should know that the solutions go away from each other, from your zeros of the factors. You got it? Yes.
Cecilia, what's the definition of a disjunction again?
A disjunction is not a range between two values. It's a range that goes in opposing directions. There's nothing in common. They are disjointed. Does that make sense? Does that make sense? All right. Ma'am?
I was just like kind of talking to myself.
Okay. I do that. All right, so I'm teaching it different from the textbook, guys. All right, look at example 2. Now we have x squared minus 2x greater than or equal to 3. We're doing every one of these, working every one of these problems as all reals,
So the domain.
not
doesn't-
integers. Correct. Domain is always all reals. All right, now how does this one differ from the previous one?
We have to make it equal to 0. Last time.
Correct. We have to move the inequality. We have to make a 0 here, so we're going to subtract 3 on both sides. All right, so we end up with x squared minus 2x minus 3 greater than or equal, not 3, Paula, 0. 0.
No, do it as a factor.
Now we have to factor it. So what are the questions we ask when we factor?
What is it equal to? No. The first one is like equal to, and then if they're multiplied, and then equal to if they're added together.
Correct. So multiplied it equals
-2.
Negative 3.
-3. Added equals -2. What are those factors?
Negative 3, positive 1.
X minus 3, x plus 1. What's the next question I ask? What are the
Points.
zeros?
Yeah.
What are the
Solutions.
zeros? All right, so what are the zeros?
Positive 3, -1.
All right, so I'm actually expecting it to go from, oh, it's going to be a closed interval, -1. I already am expecting that, right? But let's prove it. All right, so x minus 3, x plus 1. We go -1, we go 3. What's the number less than -1?
-2.
-2. All right,
So on a test, you're gonna have to ask us to prove it.
it would be good for you to show it. Show all your work, yeah. What's the number between -1 and 3? 0. I like 0. And greater than 3?
4.
4. I like 4.
25.
All right. All right. The first term, is it positive or negative when I plug in a -2?
Negative.
Negative. When I plug in -2 the second term?
Negative.
Negative. All right, so it works. Check. Going in the right direction. All right.
Maybe it's negative 3, positive 1, not negative 1, positive 3.
It's +3, -1.
No, when you do the number line.
-1 is smaller than +3.
No, I mean the. Oh, wait, no.
It's a
Sorry.
solution. Those are the
know,
solutions
sorry.
of the zeros.
Mm-hmm.
Never mind.
Okay. Now, all right, when I plug in 0 to the first term, it's what? Positive or negative? When I plug in 0 to the second one, it is
Positive.
positive. Positive times a negative is never greater than the number. It's going to be a negative value. It's going to be less than 0, right? All right, when I plug in 4 to x minus 3, it's
Positive.
positive. When I plug it into x plus 1, it's
Positive.
positive. That works. A positive times a positive will always give me a greater than 0 value.
Greater than or equal to.
It's what is the equal to? It means it's a closed interval, right? So if I were writing this in interval notation, it'd be -infinity to -1, right? The bracket is different because it's also equal to, and then it would be 3 to +infinity. All right, makes sense? We're going to use the same concept when we're going to have rationals eventually. So that means we're going to have a denominator that we're going to have to contemplate.